All right, one of our last topics. Are you ready? Table F. Looks like this. Let's talk about it. Okay, so table F shows soluble versus insoluble. Okay, so if it's insoluble, that means it makes a precipitate. It comes out of the solution. It's a solid. Okay, soluble means it's going to dissolve. Now, even with insoluble, it's going to dissolve a little bit. Okay, so soluble means it's aqueous, it's soluble. Okay, you'll see AQ after it. Let's flash back to the beginning of the year. Remember signs of a chemical change? Like color change, like a change in smell, like you see bubbles or gas produce. One of them was precipitate, and you probably forgot about it, but now it's time to like unlock that memory and bring it back. So it means when I take two clear solutions and I mix them together, I get like this. It's going to start just being cloudy, okay? But then I'm going to get a precipitate. I'm going to get that settled to the bottom, okay? So that insoluble means it's going to be a solid. It's going to be a precipitate. It's going to look cloudy at first, but then it's going to settle to the bottom, okay? And how can I tell it's insoluble? It's going to have this solid. Remember, soluble is going to be aqueous, and insoluble is going to be a solid. You see this a lot with double displacement reactions. Okay, but here you can see, look at this beautiful, beautiful reactions. Chemistry is kind of cool. So let's look at how to actually use table F, okay?
Okay, I just want to go briefly over how to read this table, okay? So I have two rules. I have soluble and I have insoluble. I have exceptions, okay? I also have, this tells me it's aqueous solutions, which remember means it must be dissolved in water, okay? So when you read this table, you find your ions. Now this says group 1 ions. It says Li plus, Na plus, etc. So that means if I flip to the periodic table, that rule applies for all of these things in group 1, just not Li and Na are not the only ones, also all of these, okay? So the rule applies for all of these. The rest are more simple because they literally tell you their name and their formula. So even if the compound is given in name form, you'll be able to look it up here. Or if it's given as the chemical formula, you'll also be able to look it up, okay? Now, since group 1 ions are always soluble, so if I go above group 1 ions, the rule for them is soluble. There are no exceptions. It means it doesn't matter. I don't care what else it's with, doesn't matter. Blah, 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 always soluble, okay? So same for ammonium, same for nitrate, same for acetate, same for hydrogen carbonate and chlorate. Always, always, always soluble. Now, for halides, and it has these three, but halides, if you remember, are halogens. So that would include anything that was in the halogens group 17, okay? So if you look, they're always, the rule is soluble, but if it's with Ag, so if it's AgCl or AgBr, okay, or Pb plus 2 or Hg2 plus 2, it breaks its rule and becomes not soluble but insoluble. Okay, for sulfates, their rule is soluble, but if one of these exceptions applies, breaks the rule, reverse, and becomes insoluble. Okay, for these ones on this side, so if carbonate is in the compound, the rule is that is insoluble unless it's combined with group 1, remember like these, or ammonium NH4, and then reverse, it is not insoluble, it is soluble. Okay, now it says for insoluble, do you see this? Compounds having a very low solubility, which means, remember, it doesn't mean totally insoluble because they are still electrolytes, because they're salts. So that's just a little bit of an overview how to approach table F.
Okay, so that was a quick overview. Anytime there is something with no exceptions, please use that. Easy peasy, always check there first because there are no exceptions. I don't care what else it's with. If Li is in the formula, bam, soluble. If chloride is in the formula, bam, soluble. If nitrate is in the formula, bam, soluble. I don't care what else is there. Easy peasy. Okay, so for example, there's one. Remember, it says group 1 ions, but that means all of that. Okay, all of them. It says Li plus Na plus, etc. That means there's more. For these, okay, most of these are coming from, well, this section anyway. These are all coming from table E, polyatomic ions. Look, there they are, there they are, there they are, there they are. Okay, so their names are here in table F, but they also are in table E, kind of all over the place. Okay. Best way is to practice. Is this soluble or insoluble? Well, we got to look at the table to figure it out, right? So K is in group 1, and then I see OH. So please, please, please don't make it harder. Why? Look at where the K is. Well, first of all, how did I know it was there? Because I had to go to my periodic table, find it. It was in group 1. There's no exceptions, which means 100% of the time, 100% of the time, 100% of the time, it is what? Soluble. Okay, what about this one? Well, let's look at the table. Okay, so let's find the pieces. So we have this piece and we have this piece. Well, this one's easy peasy because look up for both of them. The rule is soluble, 0 exceptions. So kind of doesn't get much easier than that. It's soluble. Okay. All right, what about this one? All right, well, let's find the pieces. So I only see Ag, so I'm going to point it out because sometimes people are like, Ag is here. Ag is over here, but that's not where I'm looking for it in this table in order to figure out the rule. I can only look here, okay, and here when I'm talking about rules, okay? The exceptions could cause something to break a rule, but I'm only looking there. So I only see this one. So I have to check the exceptions because this does in fact have exceptions. And look at this, AG is one of the exceptions, which means reverse, reverse. It breaks a rule. So it was supposed to be soluble, but reverse, reverse. It is insoluble. All right, so let's check this one out. Let's look at the table. Let's find the pieces. Again, remember, I'm only looking in this section and this section, right? This in order to find stuff in the table to compare. So the only thing I see is right here. So I got to check the exceptions. And look at this. There it is. So the rule is OH forms insoluble compounds, but since Ca is an exception, reverse, reverse. So what happens? Soluble. Okay, so based on table F, which has the lowest concentration? If it has the lowest concentration, that means I'm looking for insoluble. So let's look at the table. All right, so here we go. Wow, look at all this. But it turns out there's not that many different things. I see a lot of Cls, and I see Na. Okay, I also see ammonium. All right, and so all of these are, the rules are soluble. So I'm looking for exceptions. So I have to check exceptions. But what you should notice is this. Look, Li and Na, there's no exceptions here, and there's no exceptions here. Remember, I was looking for insoluble. So that means if it has Na, it's soluble. If it has NH4, it's soluble. Wait, where was K? Group 1. Okay, I think I just figured it out. There we go. Okay, according to table F, which is most soluble. So this time I'm looking for soluble, all right? So here we go. Let's find all the things on the table. There they are. They're kind of scattered all over. Some have, well, most of them have a rule for soluble, but some have exceptions. And one of them has an insoluble. Okay, so first of all, we're looking for a soluble, right? So remember I said anytime you're looking for soluble, check here first, right? 0 exceptions, less complicated. So do I see anything in group 1? Hello, yes I do. So this one turns out to be a lot easier, right? As soon as you see that Na, bam, soluble, okay? Based on reference table F, which is the best electrolyte. So again, I'm looking for soluble, okay? Now, this one is in words, slightly makes it harder, but only for the first element. So because sulfate, carbonate, nitrate, chloride, I can see those. Well, I have to assume that halides, chloride, okay? And sodium, I should know as Na. So this one is a little bit trickier. I have to look at rules and I have to check exceptions. So I'm looking for something that is a good electrolyte. Again, let's look for something that has no exceptions. So it's either going to be the thing that has sodium or the thing that has nitrate, right? Because those two have no exceptions. The other one's all complicated. But look at this. It's sodium with nitrate. They're together in the same one. So best electrolyte, there we go. And that is table F.